The video will be available online to view later. So thank you everyone who is already here for joining us today. We have a super awesome guest who we at EarthHacks are very, very close to, and he's really awesome. Dr. Stephen Fong, who is a professor at Virginia Commonwealth University in Richmond, Virginia. And I will turn it over to him to let him introduce himself, tell you a little bit more about what he does, and share a whole bunch of cool research stories with you. Dr. Fong?
Cool, thanks, Anjita. Hey everybody, so I typically like to do things that are interactive. So if you signed on, and that means all of you that are signed on now, I'll probably want you to use the chat bar and enter stuff. And if you don't, I'm literally just gonna sit here and wait for you to enter stuff in the chat. So I'm gonna forewarn you about that right now. What I did want to give focus this talk on today and just go through a little bit of stuff on is talking about air and air quality. So that's why it's called How's Your Air? So just to get started with, I wanted to ask you guys to just put into the chat bar what your major is. I just wanted to get a feel for what all of your different majors are. So just real quick, into the chat bar, just write in what your major is, okay? Interesting double major. Anybody else? Computer science. Cool. All right. So I see a nice mix of a bunch of different engineering majors out there. So hopefully some of the stuff that we're talking about actually relates to a lot of the different engineering majors. So I'm going to share my screen and oops. Let's see if that's weird. Did I lose my co-host abilities?
No, you should still be good to go.
Yeah, the share screen, I was trying it out before and it's not giving me the ability to share my screen right now.
Oh, weird. You're not seeing the green share screen in the bottom menu bar?
Well, I am, but once it comes up, I am not actually able to select my screen to actually, or to share it.
ESW backend, would you guys be able to
Yep, hold on 1 second.
Okay. And as that option is coming up.
I'm seeing everything fine on my end. You can see the button?
I can see the button, I can click on it, but when it comes up, then it allows me to select something, like it's coming up with a blank window.
Okay.
Where it's not allowing me to actually select something to share.
I made you the host. Does that change anything?
How strange. Let me try this and see if this will let me. Sorry about the technical difficulties, because it was weird before we started, I was doing this. It's allowing me to share Chrome, but not actually, oh, PowerPoint, there it goes. It just, for some reason, it just switched and let me do it. Sorry about that, everyone. So now you can see my screen. Cool. So I was going to just go through and give you a little bit of background on myself. And for all of you with the different engineering majors, my bachelor's degree is in chemical engineering, so I saw a chemical engineer out there. My master's and graduate degrees are in bioengineering, which I didn't see out there. And I've been a faculty at VCU since 2005. So I just wanted to give you a little bit of my background and tell you that partially my background had absolutely nothing to do with any of the stuff that I'm talking about. So as we're going through and talking through a little bit of this, hopefully you'll find areas from your background that are relevant to what we're talking about. And even if you don't see a direct connection, what I wanted to encourage you with is that some of these topic areas, especially air quality, you don't need to necessarily specialize and have a direct background in the area to be able to contribute to this topic area. So the other thing that I was going to ask you guys to do real quick is give me your first impressions. So wherever you're at right now, what do you think of in terms of the air quality where you're at? If you could just put some input onto what you think your air quality is, and just drop that into the chat box. Say good, bad, I don't know, poor. Some impressions that not so great so far. Pretty decent. Okay. Ooh, Southern California. So if you saw, I was in UC San Diego for a while, so familiar with that. As you go further north and closer to LA, then it gets progressively worse. Oh, Sonoma. Sonoma was pretty good. Okay, now that when you're thinking about that, what was the basis that you used for making those judgments? How did you gauge in your mind based off of what you thought would be good or bad air quality? So a lot of people, like, intuitively they react to stuff like this. If you look at these types of pictures and you're like, okay, something on the left, that's bad air quality, something on the right, that looks pretty good. And a lot of times people make those judgments based off of, you know, what they can see and some type of sensory input or something like that. Partially what I want to start with is just saying, hey, you know, maybe that's not the best way of doing things. We probably want to think about things from a non-subjective manner. You guys are all engineers, you have some quantitative background on there. So, you know, yes, this looks not great on the left. This definitely looks a little bit better on the right, but what does that actually really mean? And what does that mean in terms of air quality? So you want to think about this in terms of things that you can measure. And I'm going to take this to one specific case, and we were thinking about carbon dioxide. So even in this case where we are right now with everything kind of being shut down, I want you guys to think in your own minds what you think about in terms of carbon dioxide and CO2 levels globally. So you guys know, everybody shut down, things were locked down, not just in the US, but kind of worldwide for a while. Gas prices plummeted because people weren't driving, a lot of industry was shut down. So in your mind, do you feel like carbon dioxide levels went down? Did they stay the same? Did they go up? Even though, like, globally, there was kind of a large perturbation that happened. Think about that for a second. And see what you think about. And then I'm going to put this up. This is from the National Oceanographic and Atmospheric Administration, NOAA. So these are by month going from last June to this June. And these are CO2 levels in parts per million. Okay. Think about a couple of things that you see here. So this is January, February, March of this year. Okay. This was taken at Mauna Loa, so in Hawaii, February, March, things shut down. And what happened to the CO2 levels? Kept going up. So even with stuff locked down and shut down in the US and mostly globally, the CO2 levels were still going up. Okay. This is another one of those instances where even intuitively we thought, hey, things are shutting down and everything like that. So this must be good for the environment. This must be good for CO2 emissions and stuff like that. this is a more quantitative way of saying like, hey, you know what, we probably shouldn't be making these judgments just based off of our impressions, just based off of our observations, but actually going through and actually doing the measurements. So the first thing we were just saying, like, you know, what were your impressions based off of your air quality of where you live? A lot of times we make that judgment based off of impressions and what we observe. Things like CO2 levels, we also, you know, had this immediate climate where we're thinking, hey, a lot of stuff was shut down. There's not a lot of cars on the road and all those types of things. So it probably shouldn't have been going up as much, right? But realistically, the CO2 levels were still going up. The best estimates right now, even with all the shutdowns and stuff like that, probably reduced the CO2 emissions globally by somewhere between 4 to 8%-ish, which means a lot of that, the things that are producing CO2 for us are still producing CO2, and we're still getting these increases where this, you know, May was a peak, right? So I just want to set the basis for saying like, hey, you know, when we're thinking about air quality, we probably want to be thinking about taking measurements, getting data, and using some type of quantitative measurement when we're talking about this, and not just a subjective, oh, I look outside and it looks great out, so I can see the sky, I can see the sky and it looks blue, so therefore I think the air quality is pretty good. Because realistically, what we're talking about with a lot of the pollutants that you would think about, they're not things that you see. You know, so this is the same thing of, you know, like when you're trying to check poultry for bacterial infections in the poultry lines, and if you have somebody standing there looking for it, you don't see bacteria. Same thing with air pollution. If you're just gauging your air quality based off of what you can see, it's not a good gauge because you can't actually visually see most of the air pollutants that we're actually concerned about. Okay, so that's the first thing that I just kind of wanted to start with and get us all on the same page about. So even if we wanted to go and get some measurements now, so you can go to someplace like weather.com, right? And let's say we actually did want to do some measurements and not just do this subjectively. We wanted an objective measurement. So you can go to weather.com. I just picked this. This is where I am at, Mechanicsville, Virginia. It's going to update. Yeah, it's kind of hot here, 98 degrees. And all these types of places, you can go there and, hey, look at this, air quality index, 47, good. Okay, so I can say that the air quality where I live is good, right? How many of you guys are familiar with air quality index, and how should I interpret this number 47 that says good for me? Air quality index is one of those things that kind of comes up a lot, and a lot of people are kind of using this as a basis for judging with a quantitative number the quality of your air. So if I go to weather.com every day and I check that number, I should probably feel a little bit better about what my actual air quality is, right? Well, yes and no. So air quality index is definitely one of those good things to think about, but here's part of the reality of what we're talking about. So across Richmond, where we are, and you can see where Mechanicsville is. So I live in this Mechanicsville district right here, okay? The Virginia Department of Environmental Quality, so DEQ, in Virginia, operates 4 air quality monitoring sites. And I'm showing on Google Maps where they are. So 1, 2, 3, 4, okay? These are the 4 air quality monitoring stations that are around the Richmond area that wouldn't collect any data that's relevant to calculating that air quality index. Realistically, not all of these stations measure everything. Some of them are dedicated to only measuring one type of air pollutant. The closest one is here, which, you know, it's hard for you to be able to tell the scale on here, but it's about 15 miles away. That's about the closest station to where I'm at. So that begs the question, when you go to someplace like weather.com and you put in your location and you get an AQI index, how did they get an AQI index for where I live when there's no measurement around the area where I'm at? Okay. That's really what the part of the problem too. So even if you go that step further and say, hey, I want a quantitative measurement about my air quality index, and you go to weather.com, or there's a lot of apps out there that will tell you an AQI for where you live, realistically, those are probably also extrapolations. they probably are not actually based off of data that they've gotten from where you actually live. Okay. Hopefully you're starting to get a picture of what this looks like, and I'll go a step further. This is that closest station from the Virginia Department of Environmental Quality, DEQ. This is what their weather station looks like. This is what they actually use to measure some of those air pollutants that you're getting, okay? So every single one of these units, highlighting some of these, every one of these standalone boxes is a piece of equipment that they've installed to measure a specific type of air pollutant. All of these that you see right here are actually all particulate matter instrumentation. So these are standalone hardwired things, and this box right here, you actually have a technician that goes in there. They are stationed there on different days on a rotating basis, and the way that they actually measure particulate matter pollution is they actually go and manually collect on a filter particles and then measure what the actual micrograms per volume air that get collected in these every day, and that's how they measure particulate matter. Okay, that's just one type of pollutant that you get, and this is the setup that they use to be able to do that. And it usually takes, so they get basically one measurement a day that's collected over the course of hours for that day to be able to get one measurement point, and it's specific to the location that they're housed in. Okay. So one of the things that we've tried to do is go and expand that. So here's some, outside of that one location, we started doing things where we start putting more measuring instrumentation across the area. And this is just a snapshot from yesterday of measuring AQI using instrumentation that's spread out across Richmond to try and get a better feel for what the local variance is. When you look at that, you're like, hold on a second, it doesn't look like there's a lot of variance. Why in the world do you want to go and put more instruments out there where they don't really look like they're varying that much? Well, the answer is because all of the AQI that you see right here is calculated based off of only one thing, and that's particulate matter. Okay, so if you are just measuring AQI based off of one parameter, like particulate matter, you might not see that much variance. Okay. And this is because realistically, air quality index is a calculated value. Okay, so in different places, you might have different pieces of information that are going in to calculate AQI. So when I showed you this right here, these are AQIs that are calculated just based off of particulate matter counts. Didn't take into account any other type of actual pollutant, and particulate matter isn't very volatile. So if you have particulates that are in the atmosphere that are floating around, they mix in the atmosphere, and you're not necessarily getting a huge amount of variance in the particulate matter that you're measuring. So when we're thinking about AQI and we're going that step further and saying, hey, I want a quantitative metric for the air quality that I'm looking at, we have to take into account and remember that AQI is actually a calculated number, and depending on who's reporting it, you might actually have different pieces of information that are used to calculate AQI. So you can't just take AQI as face value. You have to dig in a little bit and see what are they using to calculate AQI, and you might need to figure out where's the closest measurement that they're using to calculate the AQI for my specific area. Like I showed you, where I live, there's no direct measurement, so they're extrapolating all the information that they have. Okay. I'm going to pause here real quick because this is part of what I want to do just to set up a little bit of the problem. So, using AQI to judge air quality is potentially misleading in a number of different ways, and I just recapped some of that. Showing you just around Richmond, monitoring of air quality is actually very, very sparse. So even though you go to a lot of places where they report AQI or they report measurements of air quality, realistically, it's probably not based off of a direct measurement. It's probably extrapolated. And so really what I'm pushing for, and I'm going to talk about in a little bit, is that there's really a need to understand some of the things that are underlying air quality, the various facets of it, and how we should be able to do those measurements. Okay. As we're going through this, if you have any questions, something like that, I have the chat box up here, so feel free to drop stuff in there, and I'll keep an eye on that as we're going along as well. All right. So with that, what else should we think about? So I just set up and told you AQI is not a great single measurement, but even if you wanted to use that, you have to think about a lot more. What else should we be thinking about? Take a second right now and drop some thoughts in the chat, anything that comes to mind. If we're thinking about air quality, what else should we be thinking about? What else do we need to put into this conversation? I was emphasizing a lot of particulate matter measurements when I was demonstrating the AQI stuff, but what other things come to mind when you think about air quality? I warned you, I'm gonna wait here until you guys actually put something in the chat box. I want to see what you guys just free associate with air quality and air quality measurements. You guys are not gonna write anything. All right, ground ozone. Good deal. I didn't talk about ozone yet. Is it important? Yeah. What other things come to mind when you think about air quality? Weather, rainfall, humidity. Yes. Your local conditions actually influence the air quality quite a bit. All right. Keep thinking about that. This is a report from the WHO, World Health Organization, from 2005. It was a pretty comprehensive report. So this is sulfur dioxide. This is another one of the things that people typically monitor when you're talking about air pollutants. So the top line here is WHO's recommendation for exposure. Okay, and it gives you, it's quantitative metrics. So the exposure in micrograms per cubic meter. There's a couple interesting things that you'll probably notice here. One is, even for this one compound, they have different time of exposure listed here, going from if you're exposed to sulfur dioxide for a year, 24 hours, 1 hour, 10 minutes. We hadn't talked about that yet. There's different consequences when you're talking about air quality to acute short-term exposure, like 500 micrograms per cubic meter in a 10-minute exposure, versus having a prolonged exposure at a lower dosage over 24 hours. Okay. And then what you see is like, hey, even though the WHO made recommendations, the adoption of those guidelines across different regions in different countries varies quite a bit, right? This probably shouldn't surprise you much right now, because you can think about the direct parallel to coronavirus, for example, where guidelines are put out and every single different place is implementing their own things based off of those guidelines, right? Let me expand this a second step. So here's some other pollutants that we were thinking about. Ozone was just mentioned. Particulate matter are the things that I was talking about before. So PM 2.5 means particulate matter that is 2.5 microns or smaller. PM 10 is particulate matter that is 10 microns or smaller. And nitrogen dioxide. So that WHO actually generated guidelines, exposure guidelines for all of these different common air pollutants, saying that above these exposure limits, you are likely looking at health impacts. Okay, and you can see the same thing for most of these. There are acute exposure and there's long-term exposure. So now there's also a time course aspect that we have to think about. So if I go back and I think, oh, I go and I check the AQI, right, on weather.com for my region, and just assume that it actually takes into account some of these different factors, I actually have to start thinking about, okay, what happens if I go there sometime and it says, hey, the air quality is actually poor? What does that mean? And how long is my exposure in a poor air quality scenario? Because it makes a difference, okay? And when we talk about it making a difference, this is what we're talking about right here. There's health effects associated with exposure to pollution, both in a short-term and a long-term manner. So most of the time when you guys are probably thinking about being exposed to air quality and poor air quality, some of these are probably things that kind of come to mind. Respiratory illness, development of asthma long-term, cardiovascular effects, right? They have some other things in here they talk about impacts on work and school. There's acute symptoms that can happen when you have a high degree of exposure, high concentration of exposure over short term. And then there's long-term effects, chronic issues that kind of come up. So these are some of the things that people commonly bring up. And one of the most common is they think about development of asthma. And if you're exposed long-term to different types of air pollutants, it's oftentimes associated with development of asthma. One of the scary things with air quality is that there's some other things that are coming up that people are finding out too, where, hey, this is disproportionately affecting children, disproportionately affecting different populations that we're seeing. And more broadly speaking, there's even effects that are not commonly recognized that people are finding out right now, where long-term exposure to low levels of air pollution can even just change and impact your basic cognitive function. So your ability to learn, read, process information can be negatively impacted by low levels of long-term exposure to air pollution. So this is really becoming a problem where there's multiple pollutants that we have to start thinking about. And there's a time access to all of this as well, where different concentrations for different times of exposure becomes a problem. And as engineers, we have to think about this from that really there's a hardware, software, and analysis challenge. So I really just, for the next couple of minutes, for the rest of this, I actually wanted to walk you through, if we're setting up this picture of this is what air pollution looks like, I wanted to just step you through, hey, some of the stuff that we're kind of doing to try and address this, where there's really no good solution to some of it right now, okay? So one of the things that we've tried doing, we've tried building our own sensor instrumentation. So we worked in conjunction with a group up in Philadelphia. And because there's all these other components that we want to be able to measure, like ozone, nitrogen dioxide, and then sulfur-containing compounds, we basically went and got some custom built circuit boards. So all of you people out there that said that you were electrical engineering, yeah, we had to go in and we were soldering and putting together hardware, basically because there is not a lot of standalone ready to use instrumentation out there that is going to measure all of the different air pollutants that we want to be able to measure. So to a large extent right now, there's a large community out there of kind of DIY efforts to make new instrumentation from scratch, design out circuit boards, try and figure out what types of sensors are available and build something to do this. There's not a lot out there right now. So, the short term is, hey, we have to try and build some of this, even from a hardware side. It's challenging to do that if you're actually the ones that are designing and building hardware from scratch. And one of the nuances once you get into this is you have to build the software to go with it. And depending on what the sensors are, right here, you're looking at 4 different sensors for 4 different chemical components, right? Each one of the sensors could actually have different sensitivity, different measurement thresholds. So every single one of these has to be treated differently. Okay. Rather than, so we started doing this up here with building these weather cubes, soldering it together. We built it to be solar powered, so we were putting solar panels onto it as well, so they could be standalone. There's a lot of troubleshooting involved. So to complement that, we were also evaluating other types of commercially available things, like this purple air sensor here that does particulate matter sensors. They're relatively small, relatively easy to install. And even there's now some of these small handheld devices that you can look at, like from Pocket Lab, that people are trying to evaluate to be able to measure air quality on a continuous basis as kind of like a handheld device. You think citizen science type efforts. There's more and more of these that are coming online, and I still have to tell you that none of them are perfect. So if we're thinking about this, even from these 3 different systems that we've worked on and evaluated, the Weather Cube, hey, it's really good because it can measure a lot of different things that we're interested in, and we can build it so that it's solar powered. But to be honest, it's really hard to build and even harder to calibrate, okay? The purple air sensor that they're talking about here, it produces pretty high quality data and it's pretty easy to use, but you need to have access to electricity, and it only measures particulate matter. So all of the chemical pollutants that you're talking about, like ozone and nitrogen dioxide and sulfur compounds, it doesn't measure any of them. The Pocket Lab, this handheld system that you're talking about here that a company is trying to put out there, it's portable, it's easy to use, can produce real-time data and push it to a phone or a tablet or something like that. But so far, the measurements are a little bit suspect. For example, if you take ozone, we bought 8 of these, tried all 8 of them out, and they all gave negative concentrations of ozone. So even if you're not a chemical engineer or don't work with concentrations, you should probably have a gut feeling that negative concentration is not a good thing. Basically doesn't exist, right? So there's still a hardware issue that we're talking about right now in order to, that needs to be resolved and addressed, even just to try and get quantitative measurements when we're talking about air quality. Digging down to this a little bit more, these are 4 different purple air sensors that we installed at that DEQ site. So you see in the background here, these are the particulate matter instrumentation that DEQ operates. And you can see that ours are much smaller, portable types of instrumentation. We wanted to set it up side by side with DEQ and figure out, hey, is the type of data that we're getting from these smaller portable instruments comparable to what DEQ measures? The first thing that we were trying to figure out is, how much variation is there between these 4 sensors? Are they all measuring the same thing? And here's a readout. Here's 2 channels. Each one of these instruments has 2 channels. So the 4th one has channel A and channel B, but they're all overlaid over the same plot. And you can look at them and you're like, hold on, for the most part, it looks pretty good. But then you can see that there are these aberrations where these like random spikes that come up, right? And some of these random spikes go into these areas where you're like, hold on a second, this is actually dangerous, right? You would look at this and say, this is probably a real signal where the air quality was bad. This looks like an erroneous signal when it said the air quality was bad. So there's a lot of troubleshooting that has to happen when you're talking about looking at some of the hardware issues. Funny thing, when you're looking at this, the practical side of this, when you're doing some of this in the field and you're working on some of this, there's not always elegant solutions to some of this. The solution to this problem, when you had something that was like this erroneous aberration here, where it may have been one channel on one instrument that wasn't working, literally what you do is you go out there with a vacuum cleaner, you vacuum the instrument and the sensor, and then try and recalibrate it after that. Okay. So this is the first level of troubleshooting you have to do when you're starting to develop new instrumentation and trying to put it into the field so that you can actually get some measurements. This is the second level of challenge that you're faced with. So this green line right here is the purple air sensor that I just told you about. This is a small portable one that we're talking about. And then we actually wanted to test this against instrumentation that the DEQ actually runs. So this blue and this red line are instrument measurements that the DEQ runs that they would use and consider to be acceptable in their viewpoint. Now, when you look at this, you're like, that green line, not so great from an absolute measurement standpoint when you compare it to DEQ quality measurements. If you're thinking about this from a data processing standpoint, what you will notice though is they all tend to trend similarly, but the actual magnitude shifts. So it's maybe a gain issue in terms of when you're actually getting the magnitude measurements. So it's possible that you could actually recalibrate some of the purple arrow measurements to more closely match the measurements that are acceptable for the DEQ, but it's not spot on, especially if you just take it out of the box and run it. Okay, so two issues that we just talked about right off the bat in terms of actually utilizing some different sensors and actually getting some measurements, variation between instruments, and then calibration back to basically accepted standard measurements. And those are two different issues that you have to think about once you're doing some of the hardware, software, and analysis issues. For you data heads out there, this is what the raw data actually looks like. So if you actually want to saw computer science out there, this is what you're actually processing when you're trying to reconcile this with the DEQ data. So you get a universal timestamp on this. So this is measuring, approximately every minute, 20 seconds. You get a particulate matter 1.0, particulate matter 2.5, particulate matter 10 measurement. So this actually measures 3 different particulate matter sizes at the same time. And as was mentioned, it actually records temperature and humidity at the same time. Here's the other level that, that gets affected. Your particulate matter counts are going to actually vary with your temperature and humidity to some extent. So you actually have to also calibrate to what your atmospheric conditions are when you're taking that measurement. So there becomes a problem, a data analysis problem in the back end, where you have to start being able to process all of this data and then reconcile it back to the DEQ, because this instrument might be taking measurements every minute, 20 seconds. DEQ takes 1 measurement per day. Okay, so now you're going to reconcile those to be able to make sure that you guys have quality data. So I'm going to recap here real quick. So large continuous air quality monitoring is technically challenging right now. It really doesn't happen. So if you guys were interested in air quality and you're looking around for getting data and trying to actually drill down and say, what's the air quality really like where I live, you probably don't have a direct measurement at this point. Okay. One of the things that I will say is we cannot let the perfect get in the way of the good. So I went through and I ran through a whole bunch of issues that we're facing, but we can't let that stop us from actually doing something. So early on, I showed you how we're expanding the map of doing particulate matter measurements, and it's only particulate matter because at least that we can get some reasonable data for. So it's a good starting point. I wouldn't say that it actually measures all the air quality parameters that we're interested in, but we'd rather start by doing something than not doing anything at all. And then one of the other things that I wanted to end with is, for all of you engineers out there, we really need a lot of help still in a lot of the different facets. So there's definitely instrumentation, tech development that needs to happen. There's an analysis that has to happen with some of this, and buy-in from the community. So we actually put these out into different areas and get measurements from different areas of the community. Okay. I'm gonna just end with a couple of quick things, talking about what are some of the things that are on the horizon to think about, just out of interest in some of the things that might be coming up. One of them is Space Force. Well, not Space Force. So you guys know the announcement of Space Force, just poking fun at it a little bit. This is something that actually is happening with NASA, where NASA is going to be launching a set of geosynchronous satellites in the US to actually help with air quality measurement. So when we said, hey, there's not a lot of large scale measurement of air quality, that's going to change in a couple years. So NASA is going to actually measure air quality across the US with geosynchronous satellites. That'll improve things a lot once those come into play. But what I'm trying to illustrate with this picture right here, which is obviously just a cartoon rendering of some of this, is there's different challenges that we're going to be faced with. There's a new dimension to the problem where if I have a satellite that is in the atmosphere orbiting Earth, it is going to be measuring down through the atmosphere. And now we don't know where in the air column it's making those measurements. So the thing that as people we're most interested in is like, hey, what's the air pollution that actually affects me that I'm breathing as I walk around, as I live in my house, when I step outside? Ground level measurements. Well, if there's a measurement that's being taken from a satellite at the upper atmosphere, it is going to have to take a measurement all the way down that air column, and it's going to be hard for it to determine what's the actual concentration at the ground level when it's taking an air column measurement. So there's a good and bad here. Good, measurement capabilities are going to be increased. Bad, it's throwing in a new problem because we don't know what the variation is going to look like down the air column. Okay. Another thing that I'm going to throw out here in the mix, just to get you guys thinking about, if you haven't already, is some of these issues with social vulnerability factors, or when you think about environmental justice or environmental equity issues. So stop for a second and think about, hey, what are some of the things when we talk about, when we think about social vulnerability factors, talking about like, what are things that disproportionately affect certain populations over others? Okay. You probably think some of those things might come to mind right now in your mind. Obviously, outside of the pandemic that's going on right now, there's also a huge push for racial justice, right, that's going on that you guys are certainly aware of. And tied to racial justice are some of the government policies that happen where there's redlining of certain neighborhoods and all these other types of things and all these policies that come into place. These are the types of things that go back into being social vulnerability factors. Okay. We work with some of the people in the city of Richmond here, and they list some of the social vulnerability factors as these. So like sensitivity, so poverty, age, race, gender, chronic conditions that people might have, and they couple it with adaptive capacity. So how well prepared are people to compensate if they are stressed or if there's something that is challenging their health, right? And the reason I bring this up is because the next iteration of this is not only do you want to be able to measure some of the air quality components, so we still have that text sensor type challenge, but you also want to figure out, where do we want to take measurements? What are the areas or what are the populations where they might be more susceptible to the effects of poor air quality, right? And these are some of the things that go into that factor of answering the question, like which populations are potentially more vulnerable, so we know where to take measurements. And by taking, some of these factors and putting them together, then you can start to generate stuff that looks like this. So City of Richmond, and you generate a social vulnerability map where what you're looking at is the darker colored blue areas are areas where those populations, based off of the factors that I just listed, are going to be more vulnerable to perturbations, to poor air quality, to challenges to their health. And so this is done by census tract. And when you start looking at that, you're like, hey, if you look at this and you start trying to measure air quality now and say, is there a specific neighborhood that is more vulnerable and the prevalence of asthma is higher, the prevalence of respiratory illness is higher? These are the types of maps that you start to figure out, are there underlying causes to why the air quality is worse in certain areas and there's different health impacts in certain areas because of social structure, okay? So I just wanted to throw that out there too, because it kind of ties into other facets of not just the science and the measurement, but how do you make decisions about where to deploy? How do you interpret some of the data once you get it back, and the health effects downstream. So I will stop there, stop sharing my screen, and hopefully a lot of that made sense. I just wanted to walk you through talking about where some of the problem was at the onset and thinking about, hey, the need for quantitative measurement, kind of where we are right now as a society where there's really not great measurements out there and some of the technical challenges that are still on the horizon, and just give me a sneak peek into some of the different things that are kind of coming up in terms of, you know, capability and other facets that probably should get woven into thinking about air quality. So I'll stop there and happily take any questions that you guys might have, or talk about whatever else is that you might want to talk about.
Thanks so much, Dr. Fong. Does anyone have any questions or anything they'd like to share? We'll give it a couple of minutes, and you can always post your questions in the chat or get in touch with us so we can send your questions along to Dr. Fong, connect you guys directly. So always opportunities. So it looks like Sylvia posted something in the chat, Dr. Fong.
You heard about this project sensor community. Let me go there real quick and see. Not this one. I have not worked with them directly. There are a couple of different, so the question was related to an open source citizen science project. And there are a number of different things that we're trying to work with. We haven't worked with that one specifically, but around Richmond, we have been trying to do a lot. We're moving more towards a lot of citizen science type measurements for this, because of trying to weave in some of that aspect of getting people to get a better understanding of what air quality is, and also around Richmond and a lot of cities, there are very distinct neighborhoods that all could be differently affected. So an open source citizen science approach is really a beneficial one, because you do education and measurement at the same time and get some of the people that might be affected involved in the process. So I'm all for it. I hadn't seen that one specifically. It's a great thing. I'll look at it later. But I'm all for the citizen science type approach. I think it really is a beneficial thing, a beneficial approach to use. Problem is that getting citizens involved with some of this right now, the instrumentation side actually is more problematic than anything else, because of, you know, I showed you like some of the things, like we wanted to use the Pocket labs to be able to do citizen science data campaigns, but the measurements are just really not great. So it's almost worse to involve the citizens in taking those measurements when they say, hey, why does it say my ozone's negative here? And you're like, then you have to explain everything, and then they're going to get, you know, it doesn't help with getting them more involved when there's technical issues. Yeah. Yeah, but if you guys are like, any of you that are interested in doing this and trying to get citizen science projects up and running, definitely get in touch with me. I'd love to talk, just so we can communicate like things that we're trying and things that we're trying to do. It's not an easy lift by any means. Kudos to anybody that is trying it. It is involved. You have to be committed to really get it going.
Yeah, it makes sense for sure. It's a very, very concentrated effort. Anyone else have any other questions or anything that they'd like to share before we wrap up? Okay, well, also, Dr. Fong, I'm so glad that you mentioned the upcoming work that NASA is doing, because I think if you didn't, I would have. So if you guys are interested in kind of learning about what, you know, that's going to entail, and like what types of air quality measurements they're going to be taking, and in what areas and over what time scales and the variables, two of the we have. I don't know if these were the ones that you were referencing, Dr. Fong, but they're Maya and Tempo. So Maya is based out of JPL, so you can find their mission page on JPL's website. And Tempo is a collaboration between NASA and the Smithsonian Astrophysical Observatory, and they also have a website that's talking about the different types of things that they're looking for. So if that's at all helpful, you know, information about that is online, and if you'd like more information on either of those things, you can reach out to me and I can get you connected with those. But yeah, thank you so much, Dr. Fong, for sharing this. I always appreciate the participatory nature of your activities, so that, you know, it's not just another Zoom meeting. It's kind of, you know, really you do have to sit and think about what you're going through, and, you know, you're always able to expose us to a lot of useful information. So we appreciate your time today, and thanks to everyone who joined. We will convene again next week for our next speaker in this series, so stay tuned about that announcement, and stay well, everyone. Thanks again. Bye.